Hey guys, back, Mr. Wood, for next lesson. We're going to be in chapter 6 now. And so, but we need jokes. I actually have 3 of them for you today. So, when should a mouse carry an umbrella? When it's raining cats and dogs. What is small, furry, and smells like bacon? A hamster. And this is the best one. What has 12 legs, 6 eyes, 3 tails, and can't see? What has 12 legs, 6 eyes, and 3 tails and can't see? 3 blind mice. So, okay. Today, I want to go over chapter 6. Chapter 6 is truly a 1 or 2 day chapter. It's not like what we've been doing lately. And we're going to go over kind of the main things and what I said in class. And for those of you that were here, is in chapter 6. There's a couple worksheets. I'll post them on Canvas. I'll post them on my website, and we'll kind of go over those. And over Thanksgiving, I'm hoping you will work on those. And I just was telling my class, if you give me an hour to an hour and a half over Thanksgiving, Monday we'll come back, we'll kind of review it, and then we're going to move into chapter 7. So, okay, so here, let me go through the notes. And again, it's not a huge section of notes in chapter 6. So here are the notes. Okay, so chapter really 6, 7, and 8, and we're going to have to get to 8 after vacation. But what we're going to be working on here after the chapter 5 test on Wednesday, Thursday, is writing equations, chemical equations. That's what chapter 6, 7, and 8 are about. So chapter 6, kind of the basics of some of the things with chemical reactions. So number 1, evidence for chemical reactions. So think about even the water testing lab and some of the demos I did. What were evidences, a visual clue to a chemical reaction? So when there was a color change, number one, when there was a color change. Number 2, when a solid form. Remember, when you could not see through the test tube, a precipitate form. Number 3, a bubbles form. And what I usually do is I put 2 and 3 together, and I said whenever there's a change of state, then a reaction has occurred. And number 4, temperature changes. So color change, change of state, temperature changes would be evidence that a chemical reaction has took place. Okay, so a chemical change is called a chemical reaction. And remember, a chemical change is when something new is produced. So we represent a chemical reaction with a chemical equation. And here's just vocabulary stuff that's going to come up throughout the class. Reactants are written on the left. So in that reaction I've got there, the CH4 plus O2 makes CO2 plus water. The CH4 and the O2, they're on the left side of the arrow, so they're called the reactants. And that makes sense to me because they are reacting. And then the products are written on the right side of the arrow. So in that equation there, the CO2 and the water are the products. And that makes sense to me too because they're being produced. So just like I said there, CH4 and oxygen are the reactants. Carbon dioxide and water are the products. And then physical state is indicated in a reaction with a lowercase letter. So lowercase s in parentheses would indicate a solid. A lowercase l would indicate a liquid. A lowercase g would indicate a gas. And a lowercase aq would indicate aqueous. And that means something is dissolved in water. So instead of constantly having to write water in the equation, we would just write in OQ or AQ. And the arrow does not mean equals to. So we wouldn't go back to that equation and say CH4 plus O2 equals CO2 in water. We would say CH4 plus O2 yields or produces CO2 or water. And a catalyst is written, hey, Mr. Conyers, I'm just videotaping a lesson, is indicated. And a catalyst is something that makes the reaction go faster without really being part of the reaction. So it jumps in, makes everything go faster, and then when the reaction is complete, it comes back out. It's a little bit like if you like to go ski at, say, Keystone or at Copper Mountain, going through the tunnel is faster than going over Loveland Pass. It's a catalyst. Well, a catalyst is indicated in a chemical reaction by writing the chemical symbol for the catalyst over the arrow. And sometimes heat is usually written in the equation, but sometimes if you see a triangle over the arrow, that indicates heat. Okay, so just some of the basics of writing equations. But the number one, if you talk to anybody that's an AP Chem or has taken chemistry before, is balancing equations. And I want to do a number of these here today. So balancing equations in any chemical reaction, atoms are never created or destroyed. This is called the law of conservation of mass. So what that says is that you can't create atoms, you can't kill atoms. The total number of atoms remains constant. So we always got to show that. And I'm going to go through, I'm going to do a number of these, and I did some in class. A lot of you were here, but you got it. Number one, you got to have the same number of each type of atom on both sides of the equation. You've got to do accounting. Number two, this is the rule. What you can do is you can change the coefficients, the number in front of the formula, but you can't change the subscripts. I always, just a little tip, I always save hydrogen and oxygen to the last. And if there is a lone element, I can use a half number. And I always hesitate in using that, but it can be really helpful. And then once you use a half number, you got to multiply all the coefficients to get rid of that. Okay, so what I want to do is there are two handouts that are going to be due. And I'll tell you what is going to be due eventually with Chapter 6 is this handout right here, which, again, most of you were in class. I started this. I mean, this will be posted both on Canvas as well as on my website. So I did some on the front. I'm going to go to the back. And then this handout, which I did not give you, and I want to work some on this handout as well. So I want to just in the next few minutes work some of these problems, balanced equations. So I'm going to tell you what's going to happen with Chapter 6. Is we're not going to have a test on Chapter 6, but you've got those two worksheets that will be due. Plus, I've got question I wrote it down, question 14, 18, and 40. And what we'll do is we will then take a quiz on Chapter 6. So that'll be it. So after Thanksgiving, we're going to come back. We're going to just kind of refresh our memory, go over this, and then we're going to move into 7, and I'll send out the quiz. Okay, so I am on this handout right here, the one that says Balancing Equations. Again, this is on my website, and this is also on my Canvas, so you can look it up there. Okay, I'm going to start at the end. Okay, so I'm going to start on number 35. Okay, so we're going to balance it. So 35 is like this. So we have Al2O3 plus carbon plus chlorine, CO plus AlCl3. Now the first thing that I always do is I always do an accounting, and I always save oxygen and hydrogen to the very end. So I have aluminum, carbon, chlorine, and again, I always save oxygen and hydrogen to the very end. And then over here, I'll do the same thing on the left and the right. So I've got aluminum, carbon, chlorine, and oxygen. Okay, now I'm just going to add these up. So I have 2 aluminums, I have 1 carbon, I have 2 chlorines, and I have 3 oxygens. So what I'm doing is I'm just figuring out, okay, how many are there of each element? Now on this side, there's 1 aluminum, there's 1 carbon, there's 3 chlorines, and there's 1 oxygen. Okay, what I need to do is I need to get the aluminums, the carbons, the chlorines, and the oxygens to be equal on both sides. So what I'm going to do here is to balance aluminum. What I cannot do is I can't put a 2 there. That's against the rules. So I've got to put a 2 here. And when I do that, that gives me 2 chlorines. But this 2 distributes to chlorine as well. So that gives me 2 times 3. You multiply, you don't add. So I have 6 chlorines. Okay, so aluminum is balanced. Carbon is balanced. Now chlorine's 2 here and 6 here. So if I write a 3 here, again, remember you multiply. 3 times 2 is 6. So now chlorine is balanced. And now oxygen, I have 3 here and I have 1 here. So I need 3, so I've got to put a 3 there. When I put a 3 there, but that threw the carbon out of balance. So now I have 3 carbons. So then I'm going to come back here and put 3. So if you look, the aluminums are equal on both sides, the carbons are equal, the chlorines are equal, the oxygens are equal. So here is the balanced equation for 35. That is technically the answer. Okay, I'm going to do a couple more of these. Okay, so let me go on to 34. Working my way up, so okay, so there's the reaction. So again, what I'm going to do is I'm going to do a counting. And again, I always say oxygen to the very end and then hydrogen second from the end. So I got sulfur, I've got hydrogen, and I've got oxygen. So I'm going to count them up. So I've got one sulfur, I've got two hydrogens, I've got two oxygens. Over here I've got one sulfur, I've got two hydrogens, and then I've got three oxygens. 1 plus 2 is 3. Okay, so sulfur is balanced, hydrogen is balanced, but not oxygen. And this is where I always kind of hesitate to use this, but it can be a real help, is to use a half number. So what I mean is if I put, right now there's 1 there. Well, if I put a 2, 2 times 2 is 4, but that won't balance the O. You can only use a half number in front of a lone element. So if I put 1.5 here, that would give me 3, and that balances it. So there's a half number. And it's all balanced. But when you use a half number, don't leave the half number. What you want to do, and every chemist will always do, is you're just going to multiply all the coefficients by 2. So you get 2, 3, 2, 2. So there is the balanced equation on number 34. Okay, let me do a couple more here, just because I want to work on this. This is definitely a very, very key thing in chapter 6. And really, it's going to be a key thing throughout the rest of our class. Okay, so let me go back up. Let me do maybe 2 more. So let me do number 32 or 33. So I've got NH4, 2, CO3, blank, arrow. I've got NH3 plus CO2 plus H2O. So again, accounting. So I've got N, C, and notice I always do O at the very end and then H second from the end. So here I've got N, C, H, and O. So if I do my accounting, I've got 2 N's, I've got 1 C, I've got 2 times 4, 8 H's, and I've got 3 O's. So again, 2 N's, 1 C, 4 times 2, 8 H's, 3 O's. Over here I've got 1 N, I've got 1 C, I've got 3 H's, and I have 2 plus 1, I have 3 O's. Okay, so I need 2 N's over here. So I'm going to put, again, I cannot do that. That's against the rules. I can't do that. So I've got to put a 2 here. That 2 distributes. So that gives me 2 N's. But now I have 2 times 3 is 6 H's and then 2 more there. So 8. Whoops, did that wrong. That is 8. Now I think everything's balanced. The N's are balanced. The C's are balanced. The H's are balanced. The O's are balanced. So there is the balanced equation on number 33. Okay, let me do one more. Okay, so number 32. So I've got NaNO3 makes NaNO2 plus O2. So again, I'm going to do accounting, and again, I'm always going to save O to the very end. So I've got Na, N, and O. Na, N, and O. So I count. So I got 1 Na, I've got 1 N, and I got 3 O's. 1 Na, 1 N, 3 O's. Here I've got 1 Na, 1 N, and 2 plus 2 is 4. So Na and N are good, but here again is the half number thing. So what I'm going to do is this. I can either get more O's here, and if I put a 2, that gives me 6. That isn't what I need. But I could get fewer O's over here. This is 1. Well, if I make this, there's again a half number only in front of a lone element. So 1.5 or 0.5 times 2 is 1 plus 2 is 3. That is now balanced. But again, don't leave it that way with the half numbers. So what you want to do is make this 2, make this 2, and make this 1. Okay, so there is the balanced equation. Okay, and again, you guys, over Thanksgiving, I need you, again, give me an hour and 15 minutes on that. Okay, the other handout, which is I didn't give you, looks like this. Okay, and this is going to be on Canvas, and it's also going to be on Canvas as well as on my website. Now, this one is a little harder. When we do the quiz, I'm not going to, I think I have one like this, and the rest are like the ones we just did. And a matter of fact, on this handout, I'm going to do 1 and 2, and I would just try maybe through 6 and then stop there. Try and just do those. Okay, number 1. So we got zinc. I'm going to draw in the blank. Plus lead 2 nitrate. So here is the test. So lead, what we had on the chapter 5 test, lead 2 nitrates 1. So it's PbNO3 2. Makes zinc nitrate. So zinc is a 2. Nitrate's a 1. So if I crisscross, plus lead. Okay, so again, I'm going to do my accounting. So I've got zinc, I've got lead, I've got nitrogen, and I've got oxygen. Okay, so I've got 1 zinc, I've got 1 lead, I've got 2 nitrogens, and I've got 6 oxygens. Here I've got 1 zinc, 1 lead, 2 nitrogens, 6 oxygens. This happens rarely, but this one's already balanced, and that does happen once in a while. Okay, number 2. So that one is good. So there's our equation. So all the coefficients are 1. Okay, so aluminum bromide. So aluminum's a 3, bromine's a 1, so it's AlBr3. So I'm writing the correct formula. Plus chlorine. And this is where you got to remember something we talked about quite a while ago. Whenever you have an element, and we call it the diatomic elements, it's in this 7 right here, or NH. If they're by themselves, they are diatomic, which means there's 2 of them. Chlorine's one of them, so chlorine's diatomic. Yields aluminum chloride, so aluminum is a 3, chloride's a 1, so it's AlCl3. Plus bromine. Well, bromine is another one of those that is diatomic. Okay, so if I go back and I balance this, so I'm going to do my accounting. So I've got aluminum, bromine, chlorine. No hydrogen and oxygen this time. So aluminum, bromine, and chlorine. So if I do my accounting, I've got 1 aluminum, I've got 3 bromines, I've got 2 chlorines. Here I got 1 aluminum, 2 bromines, 3 chlorines. So aluminum is good, but bromine is not. If you ever have an odd and even number, just a little thing that I do is I switch them around. So I'm going to put the 2 here, and I'll put a 3 there. So if I look at just bromine, 2 times 3 is 6. 3 times 2 is 6. So odd and an even number, I just swap those. But that made 2 aluminums here. So I'm going to go back, and now I got bromine balanced, but now I've thrown aluminum out of balance. So I'm going to put a 2 there. Get 2 aluminums, but now I've got 6 chlorines. Remember, this distributes. So if I put a 3 there, I have 6 chlorines. Okay, so let me get you started then on number 3, and I'll let you guys finish. So almost done. So I've got Na3PO4. So that's sodium phosphate. So sodium's a 1, phosphate's a 3. Plus calcium chloride. So calcium's a 2, chlorine's a 1, so it ends up being CaCl2. Yields calcium phosphate, so calcium's a 2, phosphate's a 3, so it looks like that. Plus sodium chloride, so sodium is a 1, chlorine's a 1, so those would cancel out. Okay, so I'll let you guys balance that one. Try 4, 5, and 6. And again, like I said, if you can just give me an hour to an hour and 15 minutes over break working on these, we'll come back, kind of wrap this up. Okay, guys, have a good Thanksgiving. After Easter, my favorite holiday. Talk to you later. Bye.